Let's take a look at example 6 of section 3.4. One of the things that's going to be very important to us is not just being able to calculate the derivatives, but also to be able to write it in the simplest form possible, because at the end of the day, we're going to start to do some analysis with these things, because we can get a lot of information about the original function f of x based upon its derivative. And in order to evaluate that derivative and kind of make some important discoveries, we want that function to be expressed in the simplest terms possible, so it itself is kind of easy to work with. Let's take a look at example 6. We want to find the derivative of f of x equals x squared times the square root of 1 minus x squared. At its heart, this is going to be a product rule because we have the multiplication of two functions. This is the product of x squared with the function square root of 1 minus x squared. Furthermore, we know that typically whenever we want to do a derivative of a radical, it's always kind of helpful to rewrite that first as being to the fractional power. So we'll rewrite the square root as the 1/2 power. And now we're going to go ahead and take the derivative by using the product rule. So recall, the product rule says that if you have a product of two functions, you do the derivative of the first function. The derivative of x squared would be 2x. Leave that second function alone. And then plus, now I'm going to leave the x squared alone. And now I'm going to multiply by the derivative of 1 minus x squared to the 1/2. Now, in order to do the derivative of that piece, that in and of itself is going to require the use of the product rule. Excuse me, the use of the chain rule. So for this one piece, we need to do a chain rule. This is the composition of a 1/2 power function, or square root, with the polynomial 1 minus x squared. The chain rule would say do the derivative of the outside function first. So I'm going to bring the 1/2 down, reduce that power by 1 to the negative 1/2, and I'm going to leave the inside function alone. And then from the chain rule, we need to multiply by the derivative of the inside function. Be careful with your sign here. The derivative of 1 minus x squared would be 0, because the derivative of a constant is 0. So the derivative of 1 is 0. Derivative of negative x squared would be negative 2x. And so that part would be negative 2x. So this is what we get. Now it's a matter of trying to see if we can simplify this thing. So f prime of x equals 2x times 1 minus x squared to the 1/2. Here, the 1/2's cancel. I'm still going to get a negative coefficient. X squared times x is x cubed. And then we have a 1 minus x squared to the negative 1/2. So far, so good. Let's try to simplify this. We have f prime of x equals 2x 1 minus x squared to the 1/2 power. And now I'm going to write this as minus x cubed divided by 1 minus x squared to the positive 1/2 power, because we want to write it with a positive exponent. And now we're not entirely done yet, because what we want to do is we want to combine these two into a single fraction. So I'm going to put this over top of 1, and we're going to need to get a common denominator here. Okay. Well, if we have terms of 1 and 1 minus x squared to the 1/2, the common denominator would be 1 minus x squared to the 1/2. This second function already has that common denominator, so there's nothing we need to do to the first. There's nothing we need to do to the second fraction. But for this first one, to go from here to here, we would need to multiply the bottom by 1 minus x squared to the 1/2, which means that we also need to multiply the numerator by 1 minus x squared to the 1/2. That's how we get our common denominator. And if we look, that's going to be the multiplication of like bases. So we're going to be able to add these two exponents together. Don't forget we have this 2x kind of sitting out in front, and then we're going to end up with the term 1 minus x squared. 1/2 plus 1/2 will give us 1. So this will now be to the first power. And of course, anything to the first power, you don't necessarily have to write it. I'm going to distribute this in. This is 2x minus 2x cubed all over 1 minus x squared to the 1/2 minus x cubed times 1 minus x squared to the 1/2. And now that we have a common denominator, we can go ahead and subtract the numerators. We have 2x, and then a negative 2x cubed minus x cubed will give us negative 3x cubed, all divided by 1 minus x squared to the 1/2 power. And now this would be our simplified form for our derivative. Again, after looking back through it, the calculus part might seem like the easiest part to you. It's just, be very careful with your algebra. Show things step by step. Continue to develop good habits where you write things out, showing all of your work step by step. It makes it less likely that you'll make a mistake. And also, in the event that you do make a mistake, it'll help you to kind of go back through your work to spot potentially where that mistake may have been. Anyway, we get our derivative here. It's 2x minus 3x cubed divided by 1 minus x squared to the 1/2 power. Let's take a look at another one that's kind of very similar. We're asked to find the derivative of this function and simplify it. First things first, before we want to apply our calculus rules, let's take the time to rewrite it to make that part a little bit easier. We can think of this as the cube root is equivalent to the 1/3 power. And then to avoid a quotient rule, which would be a little bit nasty with its denominator, we can rewrite it one step further. Let's, instead of doing a quotient, let's think of it as the product of x with x squared plus 4 to the negative 1/3 power. And now we'll apply our derivative rules to the function g, expressed like this. Excuse me, the function name is f, I guess. So we have f of x equals x times x squared plus 4 to the negative 1/3 power. The first thing we need to determine is what is the overarching or the main rule that we need to use in order to take the derivative of this. And the answer is, because we have a product, it's the multiplication of two functions. This is going to be a product rule. Product rule says we do the derivative of the first term. That's going to be 1. Leave the second term alone. Plus, now leave the x term alone, multiplied by the derivative of the second term. In order to do the derivative of the second term, that's a composition, so that's going to require the use of the chain rule. Chain rule says you do the derivative of the outer function first, so that's going to be the negative 1/3 power. We bring the power down. We're going to reduce the power by 1. Negative 1/3 minus 1, that's going to be negative 4/3. We leave the inside function alone. And then we're going to multiply by the derivative of the inside. The derivative of x squared plus 4, that's going to be 2x. So right now, this is what we have. We have x squared plus 4 to the negative 1/3. We have an x times negative 1/3 times 2x. That will give us a negative 2/3 x squared. And this is going to be times x squared plus 4 to the negative 4/3. Okay. Algebraically, from here, you can take it just like we did with the last one. You can take each of these to a denominator and do something like this. Make them positive, get common denominators and all that good stuff. Or you can use another technique, which I'll show you on this one. And that's essentially recognizing that what we have here is like terms. This term and this term are like terms. And so if you think of it like via analogy, like if you had, let's say, y squared plus y to the fourth, and somebody asked you to factor this, well, we know it factors as y squared times 1 plus y squared. And the question becomes, well, which exponent do you factor out? The answer is you always factor out the smallest power of that expression. So if you look at what we have up here, what is the smallest power? Well, the answer is between a negative 1/3 and a negative 4/3. Negative 4/3 is actually the smallest power, so you can factor out of this. X squared plus 4 to the negative 4/3. And let's see what that's going to leave us with. Whenever, let me write that again, whenever you factor out that common power, what it does is it subtracts that power from the powers that were on the inside of that term. So therefore, what I'm going to have is the following. When I factor an x squared plus 4 to the negative 4/3 out of this one, the power will now be negative 1/3 minus negative 4/3, which is negative 1/3 plus 4/3, which gives us positive 3/3, which is going to be 1. So I'm going to be left with the x squared plus 4 to the first power here. Subtract. Now this is the very thing I was factoring out. Now this term is going to be gone. And what we have is a negative 2/3 x squared there. And this allows us pretty quickly and conveniently to go to our final answer. F prime of x is equal to, this term needs to get reciprocated to the denominator to make the exponent positive. That's going to be x squared plus 4, now to the positive 4/3 power. And if you just simplify like terms on the inside, 1x squared subtracting 2/3 x squareds will give us a positive 1/3 x squared plus 4. Okay, and there you have it. Some purists would say, well, you still have a fractional coefficient here. That's okay. If you don't like that, you could multiply the main numerator denominator by 3 if you wanted to get rid of this fraction. But it looks kind of in a nice form right now. We have a nice polynomial up top, and we have some power and root function in the bottom. So there you have it. The derivative for this function is going to be 1/3 x squared plus 4 divided by x squared plus 4 to the 4/3 power. Let's take a look at another one. Here, the overarching rule within this one is going to be the quotient rule. We have a second power function composed with a rational function. So the main rule we're going to use is the chain rule. The chain rule would say do the derivative of the outer function first. That's the power function, so I'm going to bring the power down. Reduce the power by 1. That's how we differentiate a squared function. And the chain rule says you leave the inside function alone for the moment. That's 2 parentheses 3x minus 1 divided by x squared plus 3. And now from the chain rule, now we need to multiply by the derivative of the inside function. And to do the derivative of 3x minus 1 divided by x squared plus 3, that in and of itself is going to require the use of the the quotient rule. Okay. One of the things that I sometimes will advise, especially when you start to get into problems like this, to get kind of long, if you have to do any of these like secondary derivatives, it's not a bad idea to do the work kind of off to the side. That way you don't kind of clutter up the main workflow, and it's more easy to kind of pay attention to the overall main structure of the problem and kind of sift out some of the little details that are involved in it. But nonetheless, we need to do the derivative of the inside. That's going to require the quotient rule. Quotient rule says do the derivative of the numerator times the denominator minus, don't forget there's a minus sign. Now we have the numerator times the derivative of the denominator. That's 2x. And that's going to be all over the denominator squared. So what we get here is x squared plus 3 squared. And if I expand this a little bit in the numerator, we're going to have a 3x squared plus 9. I can think of this term as like if I bring it around in front, think of it like a negative 2x distributing. Negative 2x times 3x is a negative 6x squared. And a negative 2x times a negative 1 would give us a positive 2x. So we have f prime of x is equal to. Notice that what I have right now in this numerator, I'm going to write it like this. We have a 2. We have a 3x minus 1. This whole thing was to the first power. I have 1 power of x squared plus 3 here. We have 2 powers of x squared plus 3 there. All together, that's going to give us 3 powers of x squared plus 3 in the denominator. And then we have this whole thing multiplying to this separate numerator. This numerator is going to end up being negative 3x squared plus 2x plus 9 after we combine our like terms. We should try to see if this would reduce at all because it is a fractional answer. Right now, that would involve trying to factor this quadratic. This quadratic will not factor, and we don't have anything that cancels, so this would be the simplified form for our derivative. F prime of x is equal to 2 times 3x minus 1 times negative 3x squared plus 2x plus 9, all divided by x squared plus 3 cubed. And again, especially when it comes to rational functions, it's kind of might be counterintuitive to what you're used to doing. I know a lot of us from our algebra background feel inclined, or that perhaps we should actually go through the extra step of multiplying the numerator. It's actually more beneficial to us at this point in time, especially as we're going to use and analyze the derivative, to leave things in factored form. Okay, so as long as you've combined denominators and you factor as much as you can, even if it doesn't reduce, we're going to leave our answer just like this.